Hello everyone, I'm going to talk about 909 snacks and ladders. Okay, the question is given an n times an integer matrix board where the cells are labeled from 1 to square. This is writing style, starting from the button, left here, with button, and alternate direct each row. You can start on square one of the boards and each move starting from square current to the following, and choose the destination square nest with the label in the range here. And this choice simulates the results of standard 6 sides. Okay, there are always at most 6 destinations regardless of the regardless of the size of the board. If the nest has the snack or ladder, you must move to the destination of the snack and the ladder. Otherwise, you move to nest. The game end where reach the square. This one. Okay, so -1. So a board square on row R and the column C has the snack or ladders if board -1. The destination of the snack or ladder is board and square 1 and square are not starting point of any snack or ladder. Note that you only take a snack or ladder at most once per dice roll if the destination to snack or ladder is the start of another snack or ladder. You do not follow the subcurrent snack or ladder. For example, suppose the board is this one. Okay, on the first move, your destination square is 2. Okay, first step. Okay, you follow the lever to the square 3, but do not follow the subsquare ladders to the 4. I didn't understand this one actually. Return the least numbers of the dice roll and require to each the square this one. If it's not possible to reach the square, return -1. Okay, so any reason? So it's if we encounter special case, right? So we cannot achieve this one. So for this one, we can use the BFS to solve these problems. Like for example, at the beginning, right, we have 4 and we have 1. We start from 1, and we have different branch based on this one. Where this one? So which means we have the 6. It's kind of like every level means the first step, and this one means the we start right 1 step. Here we have 3, 2, 4, 5, 6, 7 branch, and actually for 2 here it has this one. It has the ladders, so we can directly go to the 15 here. So actually if we go to the here, we actually start from this one to go to the next branch. 6 here. So every time we also need to check the board here to check the value here. So let's write the code first. And then we have the visitor. Because you use the BFS, so it use the queue, implemented by the queue. And also we have the result. For last, for the one here. Now we come in here. Now pick up the cur is equal to for the first. Because this queue is first in, first out. So we start from the last one, right? And then the first one pick up. If this one, if with this one, n square is our want. So if we reach this one, we actually can return the result. So every time the while loop is mean the result. So the results mean actually this is just the result. A level of result should be +1. It's kind of this result represent the step. Every level means the one step. Except the first one. This one is already we include this one. We also calculator. One start from one. No, I mean start from the one, but for here we actually one step. First one original. So this is also this actually one. For here, 1, 2, 3, 4. Yeah. Okay, so now if we didn't return, which means we didn't find it, we can directly return the -1. Okay, so for here, I pick up 1, so for the nest, right? For the y is mean the nest. It should occur +1. And the y is also mean by the occur +6 and y ++. Then we can have the row because this is actually the index the column about this should be 0, but for here is the value of this one is 1, so we can based on some math or some rules you can find the here in the column equal to y plus column. And also we have to check because if the row, right, this is means the first, you can treat it like this is first 0, so it start from the where 6, right? 0, 1, 2, 3, 4, 5. If the row modify 2 not equal to 0, 0, 1, so which means the row the column should start from the column should start from the zero, 1, 2, 3, 4, right? If this one is equal to 4, nest. This should be the 5 array. Okay. Because the board is the stuff from this one, right? Stuff from the board, this one is 5 and this one is 0. So but actually we start from the 1, so we need to do this switch from stuff from the row to calculate. Okay, so if the nest equal to larger than 0, if the nest smaller than 0, which means the -1, right? So nest should equal to y. Visited and prepare for the next level. Which means didn't visit. Now we can visit. Offer lost nest over here. Let's see, okay, Q. Visit. Yeah. Okay, run answer for here. Except -1. Stuff from the first one, okay. Then go to this. Should be 1. Then it will back to the, okay. Okay, this. If 0, we actually okay, current row actually should start from the last this is start button. So we actually this one. Yep. And for the time complexity, this is so n times m, because you have to check, and for the space also for the same thing. You can check. Square, yeah. Same. Okay, so let's come back for talk about this one. Size. For here is the stuff from the bottom. Actually, for hero, you can, if you say 2 here, actually this one is means 0. So that's why we treated this one as 0. But we are mapping for the board. Actually, the index is stuff from 0, stuff from here. So this is got a little tricky here, but trying to use the example, it will be better. Start button, right? For this one is 0, and for the column here, it's actually is the equal to 1. So row minus 2, 0, right? The row is 0. Actually, it's what stuff from the left. But if you are doing this one, it means the row stuff from the bottom, it means 1. So we need to, the columns should start from the right side. But if you are going to the board, this is means the 0, 1, 2, 3, 4. 4, right? 4, this one is totally different. So this got a little tricky here. Yeah. Thank you.